It is life's most basic need for all beings to survive. It is not only a resource but source of life. Unfortunately, there is a crisis of our drinkable water in our world right now, as our water supply is limited. According to the World Health Organization, only 0.007% of the total water supply is safe for consumption, and this minuscule needs to be shared by 7 billion people on the planet. Nearly 1 billion people live without clean drinking water. This crisis is happening all over the world, especially in developing areas such as Sub-Saharan Africa, Southeast Asia, and Papua. Located 1 hour flight from the clearest diving spot in the world, Raja Ampat, and near the largest gold mine in the world known as Grasberg Mine. Mimika is still economically deprived and lack access to clean and safe water. They cannot just turn the tap for a nice clean water drinking. Instead, women and girls often spend more than 3 hours a day to collect drinking water from the nearest swamp that has been exposed to an open environment including germs, plastics, and even heavy metals from the mining site.
In this Papua area, many heavy metals exceed the acceptance standard level of drinking water, including lead, cadmium, copper, nickel, and zinc, in the form of toxic compounds.
There are various problems associated with this poor drinking water condition. One of the biggest problems is health. Many of them knows that drinking this contaminated water will make them suffer even more.
Several diseases such as waterborne, diarrhea, and even death are common issues for them. But what choice do they have? Going through a long wild journey to a clean water source makes the woman more likely to be attacked or sexually harassed. Also, children suffering from water-related problems are unable to attend school. Due to lack of access to clean water, people's health is vulnerable. If they are unhealthy, they are not effective in doing their jobs, which makes them unable to earn higher income to support their lives financially. This low income then limits people to have access to clean water more severe, and thus they are trapped in this horrendous cycle.
Hence, we focus our project topic in the area of water filter targeting villagers in Mimika whose water resources are under threat of harmful pollutants.
Therefore, we designed this PortaFill bottle. There are two major filtering sections in this bottle. They are a 3-layer filter cartridge and activated charcoal. This is the 1-liter bottle design. The total volume of the bottle is 1 liter, but the volume of the water compartment is 500 milliliters. The body of the bottle is made curvy for easy handling. In the middle of the bottle, there will be a small inlet pipe that is used to fill the bottle with the contaminated water. The pipe will be facilitated with a tight one-way valve so that the water that comes in doesn't get out. At the bottom, there is a pump that is used to facilitate the nanofiltration process. On the top, the design is similar to that of a sports bottle with a push-pull lid. It is also connected to a small outlet pipe so that the users can fill a big water container with a filtered water in one go, not just 500 milliliters. Villagers have to walk a long distance to get to the water source, so by filling a big water container, they don't have to waste time and energy to go back and forth.
When filling in the bottle, the pump needs to be in its extended position. After the bottle is filled, all we need to do is push the pump so that the water goes through the filter cartridge. And then all the contaminants will be filtered out. Before exiting the bottle, the water has to pass through the activated charcoal as the last stage of filtration. Microfiltration is a physical separation process utilizing membranes with very open structures. Microfiltration membranes have the most open pore sizes of all polymeric membranes. They're capable of removing large suspended solids such as colloids, particulates, fat, and bacteria while allowing proteins, salt, sugar, and other low molecular weight molecules to pass through.
Due to their small size and stable nature, waterborne pathogens like bacteria and viruses are among the most difficult contaminants to remove from drinking water sources, such as surface or vulnerable groundwater. In this product, microfiltration is used to remove bacteria and viruses from the contaminated water. We are using polyether sulfone or PES membrane with 0.5 micrometer pore size and 90 mm diameter. PES is a hydrophilic membrane that wets out quickly, which results in fast filtration with high flow rates and throughputs. The molecular formula for polyether sulfone is C12H8O3S times N units. Here are the molecular 2D and 3D structure of polyether sulfone.
The second layer of filtration is ultrafiltration. Ultrafiltration is another type of membrane filtration process. Its working principle is by forcing a liquid against a semi-permeable membrane, which is usually 103 to 106 daltons in pore size, like polypropylene. While water is passing through the membrane, suspended solids and solutes of high molecular weights are retained and brought by the membrane. After this process, bacteria, microorganisms, particulate material, heavy metal and natural organic material will be removed. It's environmentally friendly because no byproducts will be produced and no chemicals are needed in the process like coagulants and flocculates, which will not pollute our nature. And it has a good and constant quality of the treated water in terms of particle and microbial removal. Also, it has an efficiency up to 99% in removing suspended matter and harmful microorganisms.
The layer of this cartridge filter is nanofiltration. Nanofiltration deals with most of the nanomaterials that dissolve in water or other solvent.
Nanofiltration is a recent membrane filtration which has pore size ranging from 1 to 10 nanometers. In our project, this bottle, we will use polyamide thin film composite, or as known as PATFC, as a membrane materials. The method of this membrane material filter the solute differently from microfiltration and nanofiltration. The separation between solute and solvent occurs by diffusion of the molecules through this nanomaterials membrane, driven mainly by high transmembrane pressure, whereas microfiltration and ultrafiltration filter the solute through physical hole in the form of pores in the membrane itself. Fortunately, recent developments of these material membranes for nanofiltration have greatly extended their capabilities in very high pH or low pH environments that realistically suitable for water condition in Papua. These membranes tend to have a slightly charged surface with a negative charge at neutral pH. This surface charge plays an important role in the transportation mechanism and separation properties of the membrane. Therefore, nanofiltration is very effective in softening water, including removal of polyvalent cation and removal of disinfection products such as natural organic matter and hydrocarbon that dissolve in the water. Due to its ability to remove polyvalent cation, nanofiltration is nearly able to remove all heavy metals cation in Papua's water source. Therefore, people will be hindered from many health problem issues caused by salt and heavy metals contained in the water, such as cancer, rheumatoid arthritis, and nervous system diseases.
The final stage of this filtration process is going through activated charcoal. Activated charcoal is charcoal that has been treated with oxygen to open up millions of tiny pores between the carbon atom. Activated charcoal has two main characteristics that is useful for water treatment, which is porosity and adsorption. First is its adsorption ability to attract atoms, ions, and molecules from a liquid and dissolved liquid onto its surface. The second one is its porosity, which expands its surface area to make the adsorption more effective. Activated charcoal has a pore size of 2 to 5 nanometer. 1 gram of activated charcoal has a surface area of 300 to 2000 square meters. Activated charcoal is good at removing volatile organic compound or VOC. VOC are an organic compound that has a high vapor pressure at room temperature. The example of VOC is paranitrophenol and benzene. Paranitrophenol is a toxic phenolic compound that can cause abdominal pain and vomiting if ingested. Benzene is an organic compound that is contained in fossil fuel and mining vehicle exhaust. Benzene can easily pollute water. If ingested, benzene can cause vomiting, dizziness, rapid heartbeat, leukemia, and even death.
In PortaFill, the total surface area needed for each filter cartridge is 320 cm squared. For the polyether sulfur membrane, the cost is roughly $5. The polypropylene membrane costs $6, and the polyamide film compost costs $5.
The activated charcoal is packed in a capsule that has a diameter of 6 cm and a height of 3 cm. It can contain roughly 85 milliliters of activated charcoal. Activated charcoal has a density of 2.1 grams per milliliters, so we need 178.5 grams of activated charcoal for one bottle, which costs $1 for a single bottle. For the body of the bottle, we are using the polypropylene plastic. To estimate roughly, the total cost of a PortaFill bottle is $40.
As we can see, there are 4 examples of water purifier. Each of them have different focus. Just take the third one as an example. It's more suitable in hiking and camping. But when we applied this water purifier to those lived in Papua region, then it does not work. That's why our water purifier comes to play. It has a 3-layer structure which moves more than 90% of unwanted particles, and it is easier to be used and so on. But sadly to say, it is unable to remove modification salts such as sodium chloride, and it takes time to replace the filter regularly. But it is still appropriate for those lived in Papua region. Why? There are 5 criteria to measuring whether it is suitable or not. They are which: filtration speed, filtration capacity, ease of use, and cost. In this table, we can see that when PortaFill compared with other water purifier, it has lighter weight and more acceptable cost. It is easier to use for those with lower education level. Besides, its filtration speed is 1.5 liters per minute. That means people can collect clean water in a short period of time. So let's shift to how our design stepping efforts on the Papua region. In Papua regions, the water quality is poor, and the people lived there have low education level and economically deprived. Their health is affected by heavy metals seriously. So how our PortaFill improves this scenario? It can remove more than 90% of heavy metals, and it costs only $40, and it is easier to be used, which can be regarded as a simple water bottle. However, the replacement of activated carbon is still a major problem, and even though the cost of water purifier is not too high, but not everyone could afford the cost of replacement. After these projects, we find out that not just Papua region, there are still a lot of poor regions do not have clean water, like some underprivileged area in mainland China. And it is impossible to make a water purifier that meets the requirement of all the people. But one thing we can sure that is our water purifier will improve the situation in Papua. This is the end of our presentation. Thanks for listening.